Hello, math magicians. We are starting our last section of this unit. We've talked a lot about linear modeling, we've talked about functions, what are functions, we've talked about inverse functions, and we're going to kind of wrap up this whole linear ideas of a unit by talking about something that's called arithmetic sequences and series. And it leads to a very applicable real-world situation, which is simple interest. This is going to be a sequence of 3 lessons that we're going to go through that lead up to simple interest. But first, we're going to start off today with some baby steps. A sequence. What is a sequence? A sequence is a list of numbers that obey a certain rule. And to be honest, it doesn't even have to be numbers. It could be a sequence of shapes. But the idea is that there is a pattern of something that's established between each of these things that we've put in a list. So what we're going to talk about in math class is, of course, a list of numbers, but it could be a list of shapes, it could be a list of colors, it could be a list of whatever, as long as it's following some sort of pattern. Roy G. Biv, I guess, could be considered a sequence of some kind because it's following the UV spectrum, right? So there's lots of rules that we can follow, and so there's something called arithmetic sequences that follow a certain type of rule, but in general, sequences are just a list of numbers that obey a certain rule of some kind. Some basic vocabulary. Each number in the sequence is called a term. So I would say, okay, like here's the second term, here's the third term. We're talking about the third number that's in the sequence. Or what is the 20th term of the sequence? We're saying, what is the 20th number that's in this sequence? So each of those individual pieces of the sequence are called terms. When we ask about the nth term, the nth term signifies, it's a mathematical phrase that you, if you start paying attention now and ever hear somebody like to the nth degree, it's a mathematical term that represents the idea of to the very end, to the very, very end of this situation. So the nth term means the last term of the sequence. If the sequence doesn't end, then it's the rule or the formula that describes the pattern. So the idea of the nth degree or the nth term, we're talking about the very, very end of this sequence. If the sequence doesn't end, when we're saying find the nth term, it means find the formula that would describe any term that is in this sequence. And so the nth, the infinite term, would just be the infinite idea of this pattern, which is an equation. So let's just look at an example of a sequence that could happen. So a sequence example is 3, 6, 9, 12, 15. So that is a sequence. It's a sequence of numbers and it follows a certain pattern. Applying some of the things we just talked about, each term. So the first term is 3. How we represent the first term is u sub 1. U sub 1 is the first term in the sequence. And in this case, u sub 1 is 3. It doesn't have to be u. It could be a sub 1, it could be t sub 1, it could be b sub 1, etc. It doesn't have to be u, but it's any variable that is chosen to represent this situation, sub 1, as the first term. So the fourth term in this sequence, u sub 4, is 12. Okay. When we want to find the nth term of the sequence, in other words, the equation that represents this pattern, I like to make tables to try and make connections here. And so you could always make a table that represents this sequence right here. And I'm going to call this n and u sub n. Okay. So my first term is 3. N is 1, u sub n is 3. U sub 1 is 3. My second term is 6. My third term is 9. So when we're writing the nth term of a sequence, what we're doing is we are figuring out what is the relationship between the number of the term and what the actual term is, the position of the term compared to what that number is. So then here, when we're trying to find the nth term for this sequence, we're saying, well, what operation brings 1 to 3 and 2 to 6 and 3 to 9? Notice that this operation is 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So the nth term is the pattern of 3 times whatever term that number is, right? So the fourth term is 3 times 4, 12. The fifth term is 3 times 5, 15. We're going to practice this. There's actually a formula that we can follow that formalizes this process. But this is the idea of a sequence, is that it's a list of numbers that follow a pattern. You've got terms within that pattern. You can make a table from that pattern, and you can make a formula from that pattern. It's called the nth term. So let's practice this. Example 1, for each of the following sequences, first write down a general formula for the nth term, and then we're going to use that formula to find the 12th term. Instead of having to list out however many more terms, and in order to get to the 12th term, we're going to use the formula in order to say, okay, well, then this would be what the 12th term is. So first of all, writing down the general formula, my first step I always do is turn it into a table of values, because that visual representation of 1 goes to 2, 2 goes to 4, 3 goes to 6, the fourth term is 8, the fifth term is 10, helps me better visualize the relationship. How would I get 1 to 2 and 2 to 4 and 3 to 6? Go ahead and think, what would be the thing that brings 1 to the other? It is a multiplication of 2. So what we do is we say, okay, you take every single term and multiply it by 2 to n. Every number of the term, and multiply it by 2. The fifth term is 10, so then the 12th term would just be 2, and n here, these guys are connected. They are the same, which means I would do u sub 12. Well, 12 is n, so 2 times 12. U sub 12 is 24. If it doesn't make sense yet, that is totally fine. We'll get there. The next one. Again, I'm going to make a table of values. And fractions can sometimes, they are weird. With sequences, fractions are weird because we want to represent it as a whole number, but in reality, the fraction pattern needs to be separated in a numerator pattern and a denominator pattern. So when you're dealing with fractions with sequences, just look at the numerator first and then look at the denominator to try and establish what is the pattern. This 1-1 situation is kind of weird, so I'm going to put it to the side and then look at this. In the numerator, for every single u sub n, it stays 1. It never changes. So I'm going to keep that as 1. And then I'm going to look in the denominator. It goes 2, 3, 4. 2 and 2, 3 and 3, 4 and 4. So then my denominator just ends up being what my number of my term was. So it's just n. Applying that idea to this first one that's kind of strange, realize it would be 1 over 1, which simplifies down to 1. That can be another thing that's confusing about fractions with sequences, is that the fractions simplify down, and so sometimes it's hard to establish a pattern if the fractions are all simplified down. And so you have to manipulate, it's a puzzle, you have to figure it out kind of thing. But those are my 2 recommendations. Make a table and separate numerator and denominator patterns in order to bring it all together as an idea of a fraction. That is your nth term. Really quickly, finding our 12th term, go ahead and write it on your own. It's just 1 over n, which is 12. 1 over 12. All right. Sequences, that's the general idea. These are the kind of things that we're going to be doing. There are going to be 2 types of sequences in series that we look into in this class. The first one is arithmetic sequences. The other one is going to be geometric sequences, and they each follow different patterns. Arithmetic sequence is a pattern or a sequence of repeated addition. Geometric is going to be a sequence of repeated multiplication. So what that means is from number to number, you've added the same number every single time. You've added 3 every single time. So if there's a number that you've added every single time to get to the next term, that is an arithmetic sequence. The number being added which is positive, or subtracted, which means negative. I'll explain this in a second. Just go ahead and write it down for right now. Between terms is called the common difference. And it is D.